There's the live one. All right, sweet.
So I emailed you guys the presentation.
Yeah.
Yes, you did.
The only question I had on it was slide number 5. Wasn't our hypothesis, our alternative hypothesis, mu is not equal to 10, or did we do greater than 10?
I don't know, because I it seemed kind of inconsistent throughout it. Because at the end of our, where are we? Hold on. Make inference. It says that because in 11 of the make inference, it says finally state your conclusion. It says we have sufficient evidence to conclude that oranges have at least 10 sections.
Yeah. But our p-value is 0.9, right? So we're not rejecting the null, right?
I think we did. Yeah.
So our p-value can't be 0.9 if we're rejecting the null. It has to be under 0.05, right?
Yeah, but we got 100%. That's weird.
Oh,
I don't think they actually checked the whole thing.
Let me
think so
let me get George's thing.
Yeah, that is weird. I was looking at that just now. Because the p-value is 0.99. And the alpha level was 0.05.
Which means we should have failed to reject.
Right, we should have failed to reject. Which means that we have insufficient evidence to conclude that oranges have at least 10 sections. But it wouldn't have been at least 10 sections. It would have been, we have insufficient evidence to conclude that oranges have 10 sections.
Oh, you know what? Because that was because
the average orange has 10 sections. I didn't notice that until just now. I was doing when I was doing the PowerPoint, I saw that and I was like,
yeah.
That's funny because that was when I remember when Thane sent the email and said, "Oh, you have to check this and get a different p-value." Yep. So the first one that I got was lower. That's why I had rejected. And so when I changed the p-value, I forgot.
That was the one-sided. So if you did do greater than, then it would be reject. But if
and so yeah, which is why and then I went and I changed the p-value, but I forgot to change that last statement.
Okay. Yeah. So but our null and our alternative were equal to 10 and not equal to 10. So
right.
I'll reflect that in the PowerPoint. I'll update it to where we reject the null. I mean, not reject. We have insufficient evidence to reject the null.
Mm-hmm.
So what is our?
And I'll change it back to equal and not equal.
Is our p-value then really 0.99?
I didn't see where we got a copy of the data from Thane.
What are you asking about the p-value?
Yeah.
I think on the one that I had sent was
on the one that you had sent, it was 0.990. But then we wouldn't reject the null. We
would fail to reject.
Fail to reject.
Right. That should have been the right answer, but well.
I thought it was funny though, because he already graded it.
Yeah, that is funny. I don't think he really went through like everything.
Yeah, make inference and take action. We got 100%.
Yeah, I saw that.
Yeah. Maybe we shouldn't be discussing this now. The
on the live stream.
Be like, hey,
should we start a new broadcast?
maybe we should. Sorry. Are we busting ourselves?
Men in Black just kind of.
Yeah, we just got.
Anyway,
let me see what he has on the
feedback.
Well, on the no, the feedback says we're right on too. It's what it says on mine anyway. On the Excel spreadsheet for our stuff.
Yeah, I didn't. Where is the Excel? Did you send it in an email?
File is too large. Oh, it won't let me. Oh no, it's the one that George sent out.
Oh, George sent it.
Yeah.
I didn't see it. Let's see. It's in the make inference. No,
I believe, or It's in the link to the Google Doc, and then it says 2 attachments, and it has the Excel spreadsheet and the make inference Word document. Oh, there it goes. Let me download it there. Let's see if it'll pull it up now. Hopefully. So let me share, where are we? Let me share my screen real quick.
Oh, there it is.
Yeah, I'll open this up. And here's our data. And it's got a p-value of 0.009.
0.009.
0.009 greater than. But if we go not equal to, oh, I can't enable. Hold on. Oh, what did it just do? Not equal to is 0.019. Did you see that?
Oh. 0.019. So that's still reject the null.
That's reject the null. So I don't know where we got the 0.99 from, but
yeah, I'll have to update.
Is the 0.99 from the one that I sent?
Well,
yeah.
that's what you have. No, that's not one. Where did I was in a Google Doc here. Hold on, let me find it. Where am I?
The make inferences.
Here's make inferences.
Yeah, the Google Doc one is 0.990.
Oh.
Yeah, see 990.
Oh, I guess I transposed when I put that up. Well, I didn't even transpose. I changed the 1 to 9.
Well, no, I mean, because that would make it correct then.
What do you mean? What would make it correct?
Of it, like down from the observation of the study, it shows that the average orange.
And then we would say that we have insufficient evidence. Or no, we have sufficient evidence. If we just change that number to the
correct
p-value, we would correct ourselves.
Correct.
Yeah.
All right.
Oh, I see.
I'm going to correct it.
Okay. I'm not going to. Oh, here, I'll stop sharing.
0.19.
Do you need me to open that back up?
0.0196, I think. Oh, wait, no, 0.10. It's 0.02 is what it's going to round to. Right?
I can open it up really quick.
Yeah, if you don't mind.
What was it called? Making inference?
Making inference. I think. What was the Excel? Quantitative inference procedures.
Oh, that's not it. Oh, for heaven's sakes.
I can get it. Let's see.
There we go. I got it.
Okay. Oh, hey, Thane. Maybe.
Did Thane just show up?
Seems like it.
Is he going to be on the Pioneer Trail?
Oh, no, he made it back. He's got all this. Is that all your Trek stuff, Thane?
No.
Oh.
Are you supposed to be on Trek right now?
No, we leave tomorrow morning.
Oh, okay. So you won't be here Wednesday or Thursday night?
No.
Okay.
I get back Saturday at about 4 or 5.
Oh, okay. So. Okay, so where am I? Here.
P-value.
Here. P-value.
Rounded to 3 decimals.
Enable.
So Which question are you on?
Not equal to. So I've got 0.0196. No, it would actually be 0.20 because it's 1.9. It's 0.195.
Okay.
So it would be 0.020 to round it up.
Yeah.
Yeah.
I'll round it up. And then I'll have to make the change in the PowerPoint.
And then if we change that p-value, then everything else is correct, right?
Mm-hmm.
That works for me.
Okay. And then does aside from that, the PowerPoint looked all right?
Yeah, it looked great.
Okay.
All right. Yeah, somebody all right? Who's that?
I think it's the. We have sufficient evidence to conclude that oranges have at least 10 sections. Well, see, that's different then.
Yeah, so
we need to change this needs to be not equal, and the average number of sections is not equal
to 10.
10.
And then you'd have to say that not equal to 10 on the big one.
Include that oranges that the section.
How do you do the not equal sign?
I'm not sure what the actual character sign is. That's a programming not equal.
Oh, gotcha. Okay.
I don't know what the actual character for not equal is.
When I was doing it in Word, I had to go to this whole like special characters thing and
the character map.
Yeah, statistics, and I still can't get it to do it right. I mean, I don't know how they do it all. Cool. That looks a whole lot better though.
Yeah, I gotta change. I'll just change that other part here. We have sufficient evidence to conclude that oranges
are not equal to 10 sections. How would you say that? Or sufficient evidence to conclude that the average number of sections in an orange is not equal to 10.
Yeah.
You're supposed to.
We have sufficient evidence to conclude that the average
number of sections in an orange is not equal to 10. We just repeat the alternative hypothesis.
To 10. A little bit. Oops, spelled orange wrong. Okay. There we go. Sufficient evidence to conclude me and okay.
No, that all looks great now.
No, this one needs to get changed. 10 sections. There we go. Okay. Sounds good. So we can turn that one in then.
Yep.
There we go. Get it out of the way early.
Sweet.
Alrighty. Should we move on to the actual? I'll have to put a timestamp for the first meeting.
Yeah.
Where are we at? The 8:52. So about 20 minutes. Okay. Individual preparation.
All right, we ready to roll? Yeah. Or are you turning that in first?
No, I was just I was opening up my preparation documents.
All right.
And then I'm going to open up the reading just in case we run into something.
Yeah, I usually have that open too. I'm not getting this section very much. I mean, I kind of get it, but then some of it just doesn't make any sense.
Oh, the one that we're doing right now?
Yeah. It's like,
Yeah.
what are the 5 assumption checks? But then like the last 2, they're like, you can't do that. You can't do that. So just assume that it's right. Okay.
Yeah. And I did the homework for this and it
Yeah.
it doesn't really use, it only uses the hypothesis test, really. Everything else, everything else is from the previous sections.
Oh, it's just a lot of review.
Yeah.
Okay.
So.
Was there a lot of homework? I haven't even printed out the homework yet.
The homework was, I don't remember how many questions.
30-some questions.
Yeah.
Yeah, 31. And then some parts and some.
Okay. All right. So let's see. Part 2. The crocodiles.
All right. We ready to roll?
I think so.
Okay. I'll go on.
Oh, you're going to
do it.
Check the 5 assumptions for conducting a linear regression on the data. List the 5 assumptions below and explain how you checked the assumption. Include charts and graphs. So the first one is the linear.
Between X and Y.
Right, yeah, it's the error term, right?
No.
The scatter plot that the Excel sheet comes up with automatically once you fill the field in.
Right, that's the linear one. That's the one that's supposed to have a linear shape.
Yeah.
Oh. The hot dog shape.
Yep.
Yep. Or or cucumber or whatever. Yeah.
And the next one is the error term is normally distributed, and that is a QQ plot of the residuals.
Yeah.
I mean, I did. And it's supposed to be close to the line, so.
Which it was.
Yeah. And then.
Okay. And then there's that one whereby the x's are constant. You know, when they're like, fixed numbers. But then this one.
Variance of the error.
The what?
The variance of the error terms is constant.
Oh, no. Oh, yeah. That's a different one. Okay, yeah.
Okay.
The variance of the error terms is constant for all. But for that one, we use residual plot.
Yeah, residual scatter plot.
And make sure it's not a megaphone shape.
Yeah.
Which the one on the example, if you watch the TA, I mean, I swear his was a megaphone plot, and he's like, "Yeah, see, this is not a megaphone." I'm like, "That looks exactly what you just described." I don't know. This is so like into interpretation. It's really hard.
Yeah.
Yeah.
It kind of feels like statistics.
Yeah.
If I change these two words, then it changes the whole meaning of the study, and we can make this data sound like it says this.
Yeah, exactly. Well, that's not really what we wanted to do, so let's try something else. Let's change our alpha to 0.5 and see if we can't get it to work. No. And then the other two, the x's are fixed with the measure error and the observation are independent. You can't check with what we're doing in this class, they said. So we're just supposed to assume those are okay. Moving forward.
There's been a lot of assuming the past few chapters.
Yeah.
I think in the next statistics class, it'd be like, okay, remember all those assumings that we had you?
Now you're not going to do it anymore. This is how you do it.
Yeah. And then the 4 is test if there's a linear relationship. Right? Or is that what? Wait.
Right. Yeah. 4. So I've got all this up already. Do you want me to pull it up?
Sure.
All right. So share my screen. And there's, which one did I do? Okay. That one's a blank one. I don't even know why that's up. Okay, so the scatter plot is here. Right, that's number 3. Is that 3? No, 4.
No, 4.
Well, yeah, so number 3. So here's our scatter plot to test the linear. And then here's our QQ plot to test the residuals. And then here is our scatter plot to the variance of the error residual plot. So these are the residual scatter plot. And he said if you have some below and have some above, it's not a megaphone shape.
Yeah. And it also, they were saying that you want this to not be in a line so that it will be linear. And it's like, how can we have...
Right.
We want some things in line and other things not, and then it's okay.
Yeah. If this lines up, then that means that you have some relationships that are on other forms of. And it's like, what are you talking about? So I guess that's mostly of what. That's 3. So I guess we kind of missed all that, but those are our 3 assumptions. So.
Okay.
Yeah. Sorry, I guess I went backwards, and then wait a minute. Where'd I go? Oh, that's ours. We don't need that one anymore. Ugh, good heavens.
I don't know how you only use one screen.
Well, I'm used to using 2 screens at work. So anyway, yeah. So 4A state our null hypothesis. We've got B1 is equal to 0, and the alternate is B1 is not equal to 0, correct?
Yes.
For our nulls. I know the answer sheet says B1 and B2, but
I think that one's wrong.
Yeah, I think the B2 is wrong because if you go to the
the
page here,
the review section.
Yeah, it has B1 and B right here.
Yeah.
I can stop sharing right now.
And then in the homework, that was the correct answer as well.
Yeah.
Mm-hmm.
So.
And then I don't even know what you do with B because it says let alpha be 0.05, but there's
that's the answer.
That's the answer.
And then the test statistic is the T value, right?
Yes.
Yep.
Yeah.
See, I thought it was the R value. But
No, the R value is the coefficient something.
Right. That's for That's
Yeah.
for the last section.
Mm-hmm. And for the t value, we use the one for the slope.
Yes.
Correct. So it's 22.675.
Mm-hmm.
And then the p-value is like,
yeah, 0, 0, 0.
yeah, like 13
Yeah.
zeros or something like that. So we reject them all.
That almost got me when I was looking at the Excel sheet. I was like, oh, that's a kind of funky looking scientific notation.
Yeah.
Yep.
Really, really small.
So you reject it, and you
So
have
we-
sufficient evidence to suggest that there is a linear connection between the head size and the body length,
Mm-hmm.
Correct.
or head length and body length.
And that just does, yeah. Right on. Oh, and then,
The confidence intervals.
yeah.
Yeah, the confidence interval. Those are also on the Excel sheet.
Yeah.
And that's also on the slope.
It's the slope. It's the slope line.
Yep.
The bottom one.
6.704 is the lower, and 8.096 is the upper.
Correct.
Mm-hmm.
Alrighty.
Oh, now you're going to want to go to some quiz now, aren't you, Wes?
Yeah.
Mm-hmm.
And see what type of crocodiles we have to do in here.
Yeah, really.
How many different times did we files though?
Yeah, we use these crocodile files all the time.
Yeah. It's like the one in the homework for today. I mean, the homework that's due on Saturday. I think we've used that file before. What is it? Old Faithful.
Yeah, Old Faithful. We've done it a few times.
Yeah.
I'm gonna have to delete all those Excel files. That's a lot of space.
Yeah,
that's true.
I'll just keep the link to the book, and then if I need the data, I can get it again.
Holy smokes, which one are we doing? 24 or 23?
23.
23.
Oh, I accidentally opened 24. But no, it is not timed, so never mind. That's good. Thank goodness it is not timed.
Yeah, you only get 2 attempts, right?
Yeah, and it's not even timed, so I can still close it and come back to it. Like, the clock is not counting.
Yeah, it's not going to kick you out after 2 hours. It just gives you an estimated length, I think.
Yeah, which is good. So I'm like, okay, that's all I care about.
All right, where are we at? Let's see. Question 3. The true linear regression equation is y b0 plus b1, where b0 and b1 are unknown. What are the null hypotheses for b1?
C.
I think
Yeah, that's what I think as well. C.
Null hypothesis is B1 equals 0. Alternative hypothesis is B1 equals does not equal 0.
Because we didn't even talk about greater than or less than in this chapter, did we?
No.
Okay.
A residual is the difference between b0 and b1, or is the difference between the observed value and the predicted? No. I think
the
it's
difference between the
b0 and b1.
In the summary, it says the residual is a difference between the observed value of y for a given x and the predicted value of y on the regression line for the same x.
Yeah. So C again.
Oh, it is C.
Mm-hmm. 5. A plot of residual supports using linear regression when... Oh.
A plot of residual supports using linear regression when...
There's no megaphone shape.
Yeah. You see a no, you...
no, that would be that's the error. is when it's the megaphone. The residuals is the QQ plot.
Oh,
When it's normal.
the plot of using linear regression.
A plot of residuals supports using linear regression
when the residuals look normally distributed.
Yeah.
Points in the QQ plot are close to the line.
Yeah, so that would be normally distributed.
The first one, okay.
So we're going with A on that one?
I think so.
Okay, the residuals look normally distributed.
Yeah, because if it was the other one, if it was the scatter plot of residuals, it would say when you don't see a megaphone, right?
Right.
And this one says you do see a megaphone. Yeah, because it doesn't specify what kind of plot. It just says a plot.
Man, they're trying to trick us.
Oh dear. Okay, so the data. Math self-efficiency.
Okay, this one is flipped, remember. Do you see that? According to the instruction, like it's flipped. Score is the Y.
And I need the quantitative inference.
The confidence variable as the explanatory and the score variable as the response variable.
Yeah, so it's flipped. So the first set is the Y.
So score is Y.
Mm-hmm.
And confidence is X. Okay. It says compute the residuals for the data using software. What statement best describes the residuals? These residuals are between -40 and 25. Shucks, where is he? So we need the min and max of the residuals, right?
The min and max of the residuals.
Isn't that what it's saying? Or residuals form a linear pattern. Oh, we need to make a...
I think we need to make the QQ plot event. Which means we need the descriptive.
Oh, so, okay, I got that up already. Let me,
Oh.
insert table chart. Scatter plot. No, QQ plot.
They're pretty close to the line.
Okay, which one are we looking at?
Question 6, we're gonna have to make the QQ plot, and
okay.
you can do that using one of the Excel.
Quantitative, descriptive, right?
Right, right.
Yeah. Okay. Yeah, some of them look like pretty close to that line.
A is kind of right, but not because we're not testing that.
Mm-hmm.
-40 and 20.
I'd go with B, I think, on this one.
Yeah, that's what we're trying to do.
And then you gotta sort it, right?
Yeah. Smallest to largest. Or, yeah.
The residual, yeah.
Oh, yeah, that's...
Yeah, they're just
So it's
very,
all
very close to
a
the line.
linear pattern, right?
Yep.
It is.
Okay. Sorry, that took me a little while.
Me too.
Based on the QQ plot for these residuals, what can you say about these residuals? These residuals are
fairly normal.
Fairly normal. Yeah.
I would say they're almost exactly normal, but
Yeah.
Yeah.
dang flies.
Use the software to create a scatter plot of the data. Given the scatter plot, residuals plot, and QQ plot, which of the 5 assumptions about linear regression are satisfied by this data?
The variance of the error term.
So there is a linear relationship between X and Y because we have
the QQ plot and the residual.
That would be the scatter plot in a hot dog shape.
Yeah.
And I mean, cucumber shape, that's what it looks like to me. I mean,
yeah. Wait, Brenton, could I please see yours very quickly?
Yes.
Okay, I just want to confirm the scatter plot just to see if we have the same kind of thing.
The real question is, are cucumbers the same? Where you're from and where Brenton's from.
This is the scatter plot I'm getting from the information. Is that about what you have?
Yeah, looks about the same. Yeah.
All right. Okay. So A is good. The variance of error is constant for all values of X. The variance of error, that's the residual plot. So that's, so what we need to do there, we need to go and make an insert, make a scatter plot.
No pattern from the residuals, right?
No. Let me, let me share mine again real quick.
Does it look like a megaphone?
That's what I got right there.
So it looks like a megaphone then, because it's got some up top and on the bottom?
Well, no, because they said that, well, the megaphone was like, if there was like, if it was shaped like this is how they had it, kind of.
Oh, yeah.
Where you had very small towards zero on this end, and then, or vice versa. If you had a bunch down here and then it tapered down to the middle this way, they also said that was a megaphone. But since this is wide on this end and wide on this end, that would be considered not. So, right? Am I saying that correctly?
I think so.
Yeah.
Observations.
So then A and B are good. The residuals are normally distributed.
The one they're giving me.
What's that?
The scatter plot for the residuals they're giving me is crazy. But it's going by the thousands on the x-axis, and I don't know why.
Oh,
that doesn't sound right.
You can't share your screen with us, can you? You're on a different computer, aren't you?
Yeah.
Oh. Matt, always making it difficult thing. No, I'm kidding.
So I think the only one that we don't check is D. Everything else.
The value, the X values, are measured without error.
See, those are the two that we can't actually check. So how do you?
The variance of the error term is constant for all values of X.
Well, I guess.
Constant various, no megaphone shape. Right?
So the X's are fixed. The X's are fixed with measured without error. That one in the homework said that we cannot check directly.
Yeah.
Oh.
And then the observations are independent. It says you can't check directly.
Yeah.
So use this.
So it should be A, B, C then?
Which of the 5 assumptions are about linear regression are satisfied by this data? That's kind of a trick question because if you can't there's no way for us to be able to measure it because they didn't teach us how to measure those two.
Mm-hmm.
Yeah, it cannot be checked directly.
But if you're going with assumptions, they said to assume that in this class that those are good.
Yeah.
So I guess we just check them?
Let's check them and see if we get them right. That's the only way we're going to be able to do it. That's a 50-50 shot there. I mean, we know the top 3 are good.
Yeah.
Let's just try it. Yeah.
Right.
I'll turn mine in first and let you guys know.
Okay, so we're going with C.
Well, wait. For 8, we're selecting all.
We're selecting all.
Yeah.
Okay.
And then I'll turn mine in first, and if we get 100%, you guys can, and if we don't, then you guys can go back.
Okay.
So
what is B1?
Estimated slope is 8. Let's see. 12.695.
Yes, 12.695.
12.695.
Oops.
And then the lower bound is 10.674.
Yes. Upper bound is 14.715.
And p-value is
0.000.
24 zeros, right?
Oh, dear.
Yep, 0.000.
Based on the evidence using, what decision do you make regarding? Wait, which one? It doesn't ask for the p-value. Just you're doing it for the
right. Yeah, it's just It's
okay. So we're rejecting the null then.
Yeah.
Yep, because p is less than a.
Reject the null hypothesis because the p-value is less than the alpha.
Yeah.
So that's C.
C.
And then for the hypothesis test for B1, slope, if you reject the hypothesis, what does that mean? It means there is sufficient evidence, right? There is sufficient evidence to conclude that the regression line is
not zero.
Not zero.
Is that D?
Yeah.
Yeah.
Yeah, that's D. And then, okay. Oh, now we're going to use the crocodile stuff.
Yeah. What is the dependent is body length.
The dependent is the body length.
Isn't the head the body, because you're using the head to determine the body length?
Yeah, so
the head is X.
Yeah, so the head is dependent.
Independent.
No. Oh, yeah, because they're using X to determine Y. So, yeah, you're right. So pretty much, in other words, the Y is dependent on the X, correct? So the body length will be the dependent one.
Yeah.
Because, yeah, Y is always dependent on X.
I understand that the other way around for some reason.
Because, I mean, if you think about it, like, did you do the homework 23? Or even like homework 22? Remember there were on some of those where they were like, if X is this value, then what is Y?
Didn't we even use in 22, didn't we even use this same Excel spreadsheet?
Yeah.
Yeah, but then technically what I understand from math is that like Y is always dependent on X.
Yeah, it's the response variable.
So meaning that in this case, the body length will be the dependent because dependent
body length is Y.
Body length is Y, which is dependent on X. Do you get that, Brenton?
Did it say? The head length was used to predict the body length. And so we should be able to put in the X value a given head length, and it would predict a body length off of the head length.
Yeah.
Yes. Meaning the body will be dependent.
Right. So y is dependent on x because whatever x is allows you to predict y.
Right.
And so if we're trying to predict a body length, then your body length would be y, and your head length is what you're using to predict the body length. So head length would be x. So the dependent variable is the body length. No, wait, what?
Yeah. Yeah.
Yeah,
You're right.
you're right.
Okay.
Is that right? The dependent?
Hold on.
Yeah, no, check that in the book because
That's what I'm doing.
Okay.
The dependent variable is y. The independent variable is x.
okay.
Which we can use to predict the value of y for any given variable x. For the crocodile data, the independent variable is the head length, and we will use this to predict the dependent variable, the body length.
Okay.
Sometimes the independent variable, also called the explanatory variable, and the dependent variable is also called the response variable.
I think I'm going to edit my Excel sheet to have it say that as well.
So
explanatory variable, parentheses x, parentheses dependent.
So you're saying x is dependent?
No.
So Thane was right the whole time. Its body length is the dependent variable.
Yeah, because it's dependent on x.
Because dependent is y and independent is x.
Yep. I totally agree with that.
See, I read that the other way when they were. I got that backwards. I had it totally backwards. All right. Good job, Thane.
Thank you.
Extra credit.
Yeah, extra credit there.
I wish.
Now construct a 95% interval for B1. Input your answer for the margin of error. Okay, so let's throw that in.
Oh, yeah, so the margin of error is...
Do you have that up?
8.13.
It's going to be 0.
Wait, what?
It's going to be 0. Oh, wait. No, you're still looking it out, my bad.
218 divided by 2. So I got 0.443 if I U round.
Yeah.
So for margin of error, don't we use the whole number?
You take the upper bound minus the lower bound divided by 2.
Yeah, and then do you put it in with a decimal or do you put a whole number?
Did you guys already throw in your new?
Yeah.
Your new
crocodile data?
Yeah.
Yeah.
Yes.
Man, you guys are way too fast for me. Wait a minute. I just barely downloaded the stupid crocodile file.
I thought I had it, but I think this one said it was modified.
Yeah, well, yeah.
So head length is our
X value.
Oh, independent. Yeah.
Yeah.
X value. Sorry, guys.
No, you're right. All right.
Okay, there we go. So back to the quiz. So, and you said we have 8.13 for our
8.103.
Oh no, that's the upper.
That's the upper bound.
And we're finding the margin of error, right?
Okay, so
the upper bound minus the lower bound divided by 2. So 8.103 minus 7.218 divided by 2. I got like 4425, I think, which rounds to 443.
Yeah.
You mean 0.443?
That is correct, yes.
0.443. I will concur with that.
And then the lower bound is the 7.218, which is 16.
7.218.
Mm-hmm. And then the upper bound is 8.103.
103.
And then based on your lower bound and upper bound from the last two problems, what can you say about B1? 95.
The first one, we're 95% confident that the interval will contain the true value of B1.
I think that's correct. Correct.
Yeah, because
Because the chance
never
one
a
is totally
chance.
out.
Never
Yeah,
chance.
Chance is totally out, yeah.
And then there's insufficient evidence to reject the null is not answering the question.
Yeah.
Mhm.
All right. I'm going to submit.
Okay, fingers crossed.
Uh-oh. We missed a few.
We missed 2, it looks like.
8 was one of them, and 6 was the other.
8 and 6. Okay, let's go. Okay, 8, yeah. We were definitely not sure about 8.
Right.
So 6 is going to be A.
6 is A. The residuals are between negative 40 and 25.
Yeah.
And then I would bet that we only have the A, B, and C on 8.
Okay.
All right.
That's what I did. So I'll submit here. Okay.
Man, my kids keep stealing all my pants.
I get home and I have to rearrange my desk because my desk is in the family room.
That makes a difference.
So it's just ABC?
Yeah.
Okay,
And then on 6, it's A.
So we're supposed to assume they're correct, but not say they are.
Right. And so 6 you said was A?
Yes.
And 7 was C. Oh, B. See, I'm trying to screw myself here. And then 8 is just ABC.
Yeah.
All right.
Okay.
All right, I can go back and put those in later. You guys all done?
Yep.
Yeah, good.
I wrote them all down. I'll go put them in later.
Okay.
If we finish in time?
What's that?
If we finish in time?
Yeah.
Not doing too bad on time tonight.
No.
But, so how do you want to do this? Since Thane's going to be gone the rest of the week.
Do we need to do the Thursday meeting today too?
I'd say yes, because Thane is going to be gone.
Okay. Let me do this quiz real quick then.
Yeah.
Okay.
So we'll just go through the group quiz together then on that one, since it's the same as the individual preparation.
Yeah.
Dang. The number of assignments left in the semester is encouraging.
Yeah.
Because when this semester started, it was like 14 or 15 assignments per week.
Yeah.
Well, it wasn't assignments, but pieces of things to look at.
Yeah.
This is an interesting review because it's kind of like comprehensive. So.
Oh, are you in it already?
No, because I had it open a long time ago. Remember?
Oh, yeah.
When I accidentally opened it. Yeah. So I'm just browsing through the questions. And I'm like, man, it's taking us to like week 2 and those kind of stuff.
Yeah.
Hey, Thane, are you going to the Pioneer Parade thing?
So
Sure.
we're going up to the Sweetwater Crossing and Martin's Cove.
Oh, wait, no, mind. You're in Colorado. Wes is the one whom I should be asking about the Pioneer thing.
Oh, the 24th?
Yep, next week, Wednesday. No, Tuesday.
No. I usually avoid large crowds of people.
Oh, yeah? I am going. I'm so excited for it that I'm even going to buy cowboy boots. I'll tell everybody that I'm excited for Pioneer Day and I want to go to the rodeo this time because last year I didn't go. So I want to go to my first rodeo. I need to get a cowboy hat and the boots and the belt.
There you go. Celebratory.
Yep.
For the end of the semester.
Yeah.
So how many more semesters do you guys have on your degrees?
Yeah.
I have 3 more.
3 for George.
I'm only doing part-time. I only take two classes a semester, so I've got
2 years left.
Yeah, another year and a half, I think.
Dang.
Yeah.
I got about a year and a half left as well.
And I don't want to count.
Just keep your head down and keep going.
Yeah.
Yeah, that's how I feel.
Ugh.
I think I started in 2013.
Oh, goodness.
And I've just been taking part-time since I've worked full-time.
Yeah.
It's been kind of rough plugging through, though. I'm getting closer.
Yeah. Yeah. It's crazy. I'm in programming. I was kind of concerned. I hope my stuff didn't go obsolete by the time I got my degree.
Yeah, really. Ooh. So we're going to do this review, I guess?
Yeah.
Oh, man.
Sorry, I was submitting the PowerPoint. Okay, PowerPoint's been submitted.
Nice. All right.
So now all we need to do is evaluation.
47 questions? Yikes.
Oh, goodness.
All right.
We can do it. It's going to go by quick.
All right, let's see. Where are we at in the semester? Group meeting quiz. Here we go. Lesson 24. All righty. I met with my group and completed this group quiz with them. True. Which of the following are we open? Is everyone ready?
Mm-hmm.
Yeah, let me get in there. Let me answer question 1 real quick. Okay.
Yeah. And then question 2. Which of the following variables is R quantitative? So 3, that's 3 most common brands is categorical.
Yeah.
The number of people randomly selected on campus, and telephone number is not.
Yeah. So just A?
No,
no, the number of people.
C.
Yeah, mine's C.
Yeah, the number of people
in randomly selected classroom on campus.
Oh, yeah. I printed it out. So those numbers are different, but yeah, I got it. So C, number of people in the randomly selected class campus.
Uh-huh.
Okay.
Students in an introductory statistics class at BU Idaho were studying prices of cold cereal at grocery store in Roxburgh. To get a sample of coal prices, they went to Albertsons and rolled a die to decide which box from the left to top shelf they would start on. Then they recorded every 6 cereal after the first, moving from left down to the shelves, recording the name, size, and price of each cereal in the sample. Is this study an experiment or an observational study?
It's an observational study.
Yeah.
Because they had no control over the price of the individual cereals.
Mm-hmm.
So B?
Yes.
That's what I clicked, yes.
Okay.
All right. For MATH221 project, one group of students studied the ages of students on the BYU Idaho campus. They collected data from a random sample of 100 students. The sample mean was 21.2, and the sample standard deviation was 2.61. An excerpt of their data is given below. The group notices an error in their data. The age of one of the males, ID 3, was entered incorrectly. He is actually 21 years old. When the error is corrected, what will happen to the sample median? ID 3. Oh, so from 12, he wasn't 12, he was 21, which means the sample median will increase.
Increase, yeah.
Okay.
The time to complete a standardized exam in the BYU Idaho Testing Center is approximately normal, with a mean of 70 minutes and a standard deviation of 10 minutes. Using the 68, 95, 99.7 rule, approximately what percentage of students will complete the exam in under 50 minutes? Give your answer accurate to 1 decimal place. Well,
now we got to do the
standard
calculation. Yeah, we got to do, so it's, what is this? So the mean of 70, a standard deviation of 10, using, oh, we got to have the normal probability applet.
Mm-hmm.
And so what's the z-score for, what percentage will, under 50? Oh, so it's 50 minus, 70 minus,
70 minus 50.
minus, yeah.
It's not 70 minus 50?
I think it's 50 minus 70.
50 minus 70.
Divided by the standard deviation, which is 10, which is -2, is the z-score. And so the z-score of -2 is...
Don't we have to divide that by the, how many? Oh, no, never mind.
No.
I'm thinking, never mind.
That's the
other one.
Is that z-score?
Z-score is what? X bar minus mu divided by standard deviation?
Because this one doesn't give you how many students there were, right?
Right, you're right.
Yeah. Mm-hmm. So, yeah, we're going to do the z-score and then put it in the applet.
Well, I think it says using the 68, 95, 99.7, so it's 95.
No.
No?
It'd be 2.5.
2.5 is the z-score, you're saying?
No, that's the percentage.
Oh. Approximately what percentage of students will complete the exam in under 50 minutes? Oh. So it's, 2.5. 95, it's 100% minus the 95%.
Yeah, but only
divided by 2.
Wait, what? I'm confused.
So using that rule,
what was our z-score?
The z-score is -2.
-2.
And so it wants to know the students who will score below or will finish in under 50 minutes. And so you're doing less than. And so if you take 100%, minus 95% of the people who are going to finish within the z-score value, the probability of getting people who are going to finish in under 50 minutes is 100 minus 95% divided by 2, because you're only taking the bottom.
So that is that 0.025? Is 2.5%?
2.5.
2.5?
It says to give your answer in decimal, but if it's 2.5%, wouldn't that be 0.25?
That's interesting. Yeah, I don't know if it wants us to do, because in the example it does 24.7.
Yeah.
That's to one decimal place, but like I said, it says.
No, wouldn't it be 0.025?
Yeah, that would be a decimal of 2.5 of 2.5%.
Yeah, so it could be
So it would be rounded to 3.
No, it would be 2.5. It would be 0.025 exactly.
Oh, okay. Yeah.
Oh, wait a minute. Give your answer to one decimal place.
Yeah, I think it's supposed to be 2.5.
So 2.5.
Yeah.
What percentage of
It
students?
has that way.
Yeah.
Hey, I'd rather get my pen and record this so I can remember.
Man.
This one is very important that it be noted. I can feel it.
So because we got the z-score of 2, we use the 95.
Correct.
Because that's the second.
That's the rule.
Yeah.
Because one deviation would be 68,
And
2 deviations is 95, and 3 deviations is 99.7.
Yeah.
Yes.
Okay, man, that's a long time ago. Sorry, I'm not prepared for. I didn't get prepared for this exam as best I could. Sorry, guys.
But
No,
how did you determine that this one is 2 deviations?
it's
Because
the 70. Yeah.
Because what?
Where is the mean? It has a mean of 70, but it says under 50, so it's 50 minus 70, which gives you 20, and then you get this the z-score by dividing that by the standard deviation of 10.
Okay.
So you're 2 deviations away from the mean.
Oh, okay.
Which gives you the 95%. And then from there you minus that from 100%, which leaves you with 5%, but you only want the lower half of that 5%, which is 2.5.
So we take 100 minus 95 because 95 is the 2, right? Is
right.
the second.
Right. According to that rule, it's.
And then after that, we divide it by 2. The figure that we get, the 5 divided by 2. Okay.
Right, because it's less than.
Okay.
If it was not equal to.
Okay, so meaning that if the z-score is equal to 3, we're going to use 99.7.
Right, yeah. If the z-score was 3, we'd use 99.7.
And then divide by 3.
No, divide by 2.
Oh, it's always divided by 2.
It's always divided by 2. If it's greater than or less than. If it's not equal to, then you'd use the full number, no division.
Okay, always divide by 2 if it's less than what?
If it's greater than or less than.
Okay, gotcha. Okay, this is important. Thanks.
Mm-hmm.
Okay.
Are we good for question 6?
Mm-hmm.
Yep. Is that me?
Yeah, you go for it.
Scores on the LSAT are approximately normal with a mean of 150.7 and standard deviation of 10.2. Queen's School of Business in Kingston, Ontario requires a minimum LSAT score of 157 for admission. Find the 35th percentile of the LSAT score. Give your answers accurate to one decimal place. Use the applet. So I'm going to share my screen here real quick because I've always
35th percentile.
I've always been confused about this one. So here's our probability, right? So if we put, isn't this the percentage up here? Don't you put in 0.35?
I think so. Yeah. and then hit enter.
Enter. Okay.
Okay, and then those are your z-scores. So your z-score, and so it wants to say what's the 35th percentile. So is it the z-score times the standard deviation? And then you sum that and the mean to get your answer?
Wait, what? Sorry, Russ. So you plug in the 0.35 and get the z-score, and then what do you do with the z-score?
You times that by the standard deviation, which gives you how far the 35th percentile is from the mean.
Uh-huh.
And then you add that to the mean. Or subtract it from the mean, because it's lower.
Mm-hmm.
Right?
Percentiles.
Or you would use the lower z-score, rather, and still add it. So it would be, let's see, 35 percentile gives you 0.35, gives you the z-score of 40, negative 45.454. 0.4. Oh,
Negative 0. Okay.
oh man.
So you add that to the mean. No, you times that by the standard
0.454.
deviation.
Times it by the standard deviation, which
Okay.
is 10.2.
And then you add it to the mean.
And then you add that to the, well, make sure you use the negative z-score. So it should be negative 4.6308 added to
The 150.7.
0.7.
Man, where are you getting this equation? 'Cause I'm lost.
Yeah. Yeah.
I'm trying to find it in the.
I'm not sure. That was just me thinking. But 0.69.
I mean, I remember that we had to do something with that z-score, but I can't remember.
Finding the percentile. Let's see.
Are you just Googling?
No.
Oh.
I was going to look. I was going to do. It's in the first review, correct? Just chapter
3.
Chapter 3 is the first review? Oh,
no.
Describing quantitative data.
Has the percentiles and.
Okay. I'll be back in just a second.
Okay. Quartiles and percentiles, lesson 3.
Percentiles is a word. Percent means divided by 100. This can help you remember that the percentiles divided in the data into 100 equal groups. But that's not giving me the.
I wonder if is it from the left? You highlight the left to get the 35th percentile?
Yeah.
Not the center? Because the 35th percentile means if you're at the 35th percentile, that means you are greater than 35% of the data numerically, right?
So I'm sharing my screen again. Are you talking about this side here? Would that be the 35th percentile there?
I think so.
So are we supposed to?
I'm not
So is that just 0.35 0.385 is that doesn't make any sense.
Is the z-score, but
is the z-score. And then from there, I think you would turn it into, you would take the z-score and turn it into,
yes. What's our equation to move that way?
Right, yeah. I'm doing the same thing, trying to find the percentiles and quartiles.
You know what, I'm downloading this right now. The review from exam 1. I'm going to try to open that up and see the PowerPoint and see if it.
Oh, we only need 9 divided. Okay, the second divider, the word percent means divided by percentile numbers.
Okay. So, lesson.
Oh, 25, 50, 75. That makes sense. And then first percentile, second percentile. Calculated in Excel. But you need the data set.
Because in Excel you could, but you need the data set. But based on the formula that you gave, I got mine to be 146.07. No, 069.
But I don't know if that was correct.
How do I
wonder if it would be.
So I'm seeing some in chapter 5.
Okay, so
but
I've got this on. Let's see, the SAT required for admissions to BYU's. The scores on the SATs are approximately normal with a mean of 150, standard deviation of 9. So the SAT is 1%. So question, find the 40th percentile of the SAT test. So follow this order. Highlight the left portion of the applet. Input the percentile in the area. Grab the z-score and put it into the z-score equation and solve for x. And then here, I'll share again.
Because the z-score equation is...
Share. Let me share with this real quick. I'll open this up. So well, the z-score equation is right up here. Z equals x minus mu divided by O. So on our probability, we have
5.
Oh, and you're solving for x.
So is it negative 0.385 is equal to x minus, what's our mu? Our mu
150.7
150.7
over 10.2
divided by 10.2. Right, so do we do negative 0.385 or does it matter?
Yes.
Yeah, negative.
Have it negative.
Oh, the negative, you're on the left side. Okay, so.
5.
Okay, I may have to edit my notes again. So.
Okay, so we're going to times both sides by 10.2, right?
Yeah.
So negative 0.385 times 10.2, and that'll get the 10 out of there. And then x minus 150.7. So if you add 150.7 to both sides, plus 150.7, you get 146.773. That's supposed to be our 35th percentile would be a score of 146.773.
Yeah.
Okay, so from where you get the negative 0.385, what do? You multiply it by the standard deviation?
I'm still sharing, right? Okay.
Okay.
Yeah.
So normal probability. So you highlight the left side, put in your percentile up here. That gives you the z-score. Then you go to the z-score here. You put your negative 0.385 here. And then your standard deviation, or your mu, which is 150.7 here. And your standard deviation here, which is 10.2.
Oh, and so we find the
x. Solve for x.
So the x will be the 35th percentile.
Yeah.
X will be the 35th percentile score.
And what did you get? 146.773?
Yes.
Yeah.
Okay, so I just redid what I did previously, and it still worked.
You jerk. No, I'm kidding.
Because before I was using the center section highlighted at 35. But yeah, so if you take that z-score times it by the standard deviation and then add that to the mean,
yeah,
that gets you the same.
Did you multiply it by the standard deviation with?
Yeah, so you take the z-score that you got times that by the standard deviation and then add that to the mean.
Yeah.
When I do that, I get 147.13.
That's the right way to do that?
Well, yeah, because if you have, because you're dividing by 10.2 on the one side. So if you times the z-score by 10.2, the standard deviation,
yeah,
and then you add your mu, that'll give you the x.
Sweet.
Yeah.
Is that what you had? Is that what you said at the very beginning?
Yeah.
So we just waste like 10 minutes?
Except for finding you had to highlight on the left. That's the only part of my spiel that I got wrong.
And so what do you get now? 147.13?
146.773.
Okay.
So this says to be give your answer accurate to one decimal place.
Uh-oh.
So we're going to put 146.8.
Yeah.
Yeah.
Yeah, that'll be the 146.8.
And we're going to be here all night if this takes us this long. No.
Say that.
No, they shouldn't be that hard. The hardest part is the earlier stuff because it's so far away.
Let's review.
So far removed.
All right.
I'm going to pull up the other two.
A team of dermatological researchers were studying skin cancer among 60 to 70-year-old American men. Suppose you were a part of the research team and take a sample of men from this age group and calculate the mean number of skin cancer spots in the sample. Also suppose that it is known that the distribution of the number of cancer spots is right skewed. Suppose the sample size of the study was 2. What would be the shape of the distribution of sample means? Right skewed.
Yeah, I guess skewed right, but it's hard to tell with just 2.
Yeah.
Well, no, if it was just 2, it would still be on the skewed right because there's not enough to normalize it, right?
Yeah.
Well, yeah, it's just, if you had one high and one low to the right, or no, it'd just be one and then one to the right.
All right.
So we're going with A on that?
I think so, because it says it's skewed right.
Yeah.
And the only way to unskew it would be to have a bigger sample size.
Yeah.
Okay. They're trying to trick us again.
Yeah. We got 40 more tricks to overcome.
No worries.
So tanker trucks are designed to carry a huge quantity of gasoline from refineries to filling stations. A factory that manufactures the trucks claims to manufacture tanks with a capacity of 8,550 gallons of gasoline. The actual capacity of the tank is normally distributed with a mean of 8,544 gallons and standard deviation of 12 gallons. Suppose that a simple random sample of 20 tanks is selected and the sample mean capacity is found to be 8,550 gallons. What is the z-score corresponding to the sample mean? Round your answer to the 3 decimal places.
So this is going to be 855 or 8550 minus 8544 divided
by 12,
which is 0.5, which is the z-score.
And then don't we divide by the square root 20?
Yes.
Oh, wait,
Yes.
yeah, how is that? That's...
Yeah, because we have the sample of n is equals to 20.
Yeah.
It's the standard deviation is divided by the square root of 20.
Yes.
Yeah, and then we get 2.236.
Oh, I see what you're saying. So 12 divided by the 20, or the square root of 20.
Of 20.
Yeah, we skipped the step. 12 divided by that is 2.6, and then that is you divide 6. You divide 6 by the 2.6832, right? Because 6 was the difference.
Yeah. So
I get 2.236.
Yep, that's what I got. 2.236.
And that's the z-score. What is the probability? Or did you?
Yeah,
you get it right?
That's exactly what I got. 2.236.
What is the probability that the sample mean capacity of 50 randomly selected tanks will be greater than 8,540 gallons? Round your answers to 3 decimal places. So 85.
So 8540 is going to be our mu in this case, correct?
Right. So you'd take that and you'd find the difference between that and the mean. So 8540 minus 8544 is 4.
Square root of 50.
And then we change the square root to be 50 instead of 20.
Right. So square root of 50, and then you take 12 divided by the square root of 50.
So you're going to get negative 2.357 as your z-score?
And negative 4 divided by, no, times, sorry. Negative 4 times, oops.
No, it's divided.
4 divided by...
Oh, it is divided?
Divided by 50, square root of 50, right?
Yes.
Yeah.
I got 2.357.
Negative?
Yeah, I got negative 2.357.
You guys got negative?
Yeah, because, okay, on the top number, did you take the 8550 minus the 8544?
Oh, 8540 minus 8544 is negative 4. So then that would be a negative 2.357.
Oh, and you're looking for the probability, right?
Which means you're gonna get the z-score and then put it in the applet.
And then what's the probability of what?
Being less than that.
So the left.
Skew. Oh, is it left?
Yeah.
What is the probability of sample mean? It's like the tanks. No, it's greater. Greater than.
It's gonna be the middle and the right.
Yes. Yeah. Which I get 0.9908.
Yep, that's what I got. I got 0.9908, which ended up being 0.991.
Hold on.
Let me highlight the right side.
It won't let you highlight the right side?
Yeah. I can highlight the left.
Did you guys get the 2.357 for a z-score.
Negative 2.357.
Yes.
Yes, we got that, and then we put it in the applet, and then we highlighted the middle and the right side because it says greater than.
Oh.
Here's what I got. This is what
it?
mine looks like.
Oh, I didn't have the middle section figured out too. So because you had a negative score, you went from the left red line greater than would be all the rest of it. Okay.
Yep.
That makes sense.
Huh. So it's 991.
Yep. 0.991.
0.991.
That's the probability.
Did you get it, Thane?
Yeah.
Okay.
But I don't know why it still won't let me highlight to the right. But oh well.
You tried turning it off and back on again?
No.
That's what they always tell you in IT.
That's a typical IT response.
Is it my turn for 10, or are we still working on?
Oh, I think 10's good to go. Let's go.
All right. Which one of the following best describes the notion of the significance level of a hypothesis test? The significance level is the probability of obtaining test at
Type
least
1.
as extreme.
Oh,
No,
I think it's type 1 there.
Yeah.
The probability of a type 1 error.
I remember seeing that. Are you guys for sure?
Well, the probability of obtaining a test statistic at least as extreme as the one you calculated is p-score.
Yeah.
And then type 2 error is dependent upon type 1 error. And then the probability of rejecting the null is
A type 2 error.
Man, I know I had that printed out somewhere once before.
yeah, it's either B or D, but I'm pretty sure it's B.
I'll get it here. Hold on. I know that's in one of the PowerPoints.
PowerPoints.
I just gotta.
Better safe than failed.
Yeah, I know. It says exactly that too.
Yeah.
And then review link attached to. There it is. Download. That's under.
Hey, no. I found this with a USB on it.
Okay.
So I can play.
You found what?
I can play Super Nintendo games on my computer now.
Nice. You know they're coming out with one of those, the little boxes that have like all the Super Nintendo, the retro ones. Yeah, we had an Elder's Quorum like game night, and we had one of those out, and we were playing like we had an Atari and one, so we were playing Space Invaders and Frogger, and then we flipped over to like Junior Donkey Kong, and we were doing all. I mean, it was crazy.
Did you find? Oh.
Yep. Let's see. Well, I found p-value, the probability of obtaining a test statistic that is at least extreme or more extreme than your sample, assuming the null is true.
That's the p-value, right?
What are we looking for?
We're looking for the level of the significance level, or the alpha.
Level of significance, also known as alpha, the probability of committing a type 1 error.
Yeah.
That's it.
Bam. Type 1.
Error.
B.
Okay. B.
Okay, question 11. The heights of young adult females in the United States are said to have a population standard deviation of 2.6 inches. A sample was taken from N85 young adult females at BYU, Idaho, and the mean was computed to be 65.4 inches. Which of the following explains explanations describes the correct way to interpret 95% confidence interval for the problem. True mean
the true mean height, which is C.
In the United States is somewhere.
Yeah, the one that approximately 95% of all 95% confidence interval that could be computed from the population of all adult females in the United States will contain the true mean height.
Is the last one also true?
Oh, the last one could be. We're 95% confidence the true mean height is somewhere in our confidence interval.
Yes. Yeah. So
wait. So it's C and E.
And E, yeah.
So let me read these off.
It's not the chance.
There's how to correctly interpret 95%. So we are 95% confident that the true mean is between the upper and lower bounds, and approximately 95% or all 95% confidence intervals would contain the true mean. Those are the two correct ones.
Okay,
so
that's
C
what we
and
have.
E in this case.
So C and D.
Mm-hmm.
C and E.
E.
A, B, C, D, E.
Because D is a chance.
Yeah, we don't want
D
chance.
is a chance.
We don't take chances, no. Okay, so 12. Marine biologists have been studying the effects of acidification of the oceans on weights of male beluga whales in Arctic Ocean. One of the studies involves a random sample of 16 beluga whales. The researcher want to create a 95% confidence interval to estimate the true mean weight of male beluga whales. Their data follow a normal distribution. The population standard deviation weights of male beluga whales is 125 kg, and researchers feel comfortable using this standard deviation and the confidence interval. Are the requirements for the use of confidence interval met? So the random sample is 16. Is that large enough?
No.
It's not, because it should be 30 in order for it to be considered large enough. So
yeah, because does it say? It says.
Yeah,
doesn't say that they're normal.
One.
Follow a normal distribution. They're data normal.
They don't follow a normal distribution. So I think the last one, no, the distribution sample is not normal because the sample size is small.
Well, I think it says that their data flow is a normal distribution, right?
Right.
Really?
So what are the two conditions?
Oh, they follow normal distribution.
Simple random sample and normal distribution, right?
Right.
Yeah.
Oh, so we'll have to then means
because
we'll
the
go
data is normal. So it says the
distribution
distribution of the sample means is normal, because the
because
data,
the data
are normal.
normal. Okay, gotcha.
Does that sound right?
Yep.
So
I think so, yeah.
The B, right?
Right.
Okay, and then 13 we should download another Excel file.
See, it's starting to click. Things are starting to go. We're starting to move. We're starting to hustle.
Let's see. Rates of return.
An investor with a stock portfolio worth several $100,000 sued his broker and brokerage firm because he felt that a lack of diversification in his portfolio led to poor performance for many years in a row. In an effort to avoid close public scrutiny, the firm agreed to settle the conflict by an arbitration panel. The arbitration panel compared a sample of 39 months of investors' returns with the average of the Standard & Poor's 500 stock index for the same period in order to determine whether there was a substantial decrease. The data is recorded in rate of returns. The S&P has a known population mean return of 0.95. Suppose that you are a member of this arbitration panel. Conduct a hypothesis test to determine if the investor's portfolio performs significantly worse than the performance of the S&P 500. Okay. So.
Wait, so we're using.
I think descriptive is the one we want to use.
Gotta open another Excel file.
So we're doing
Have 6.
We're doing a one sample t-test though, right? Because it's giving us
Yes, one sample t-test.
No, so that's in inference.
Yeah.
Mm-hmm.
Why does it always ding one at me? Every time I do something, it dings at me.
Okay, so we're in a one sample t-test.
Okay.
Where are we at? P-value?
Is
0, 0, 0, 0.
See, I have a p-value of 1. Why do I have? Oh, because I have greater than probably. What are we looking into? Not equal to?
Suppose that a member of conductor worse use the level of worse.
so
So it
less.
might be less than.
Okay, so
Yeah, but that's still scientific notation, isn't it?
Yes.
I got 2.1 or 2.61184E14. Is that what you guys have?
I have.
E14. Yeah, 2.61184 E14. But then, I mean,
I must have the wrong data then.
I'm just a little bit curious about the null hypothesis for this one.
Yeah. Oh, we do need to change that to 0.95 because
No,
that's
0.95
Yeah.
that is the level of significance.
Oh,
but
That's the
no
confidence interval.
rate of return.
yeah, the null hypothesis is.
Population mean return of 0.95.
Oh, the mean
That's
return
the
of
null.
0.95.
Yeah.
That's the null, isn't it?
Yeah.
Yes.
Okay, so the null is the same as the confidence interval.
Well, that
in this
gives
case.
us quite a bit difference p-value.
Yeah, I get 0.019.
So you guys, on your guys' one sample t-test, do you have N is 39, a mean of negative 1.107,
Yes.
standard deviation of 6, and a error of the mean is 0.961?
Yeah.
Okay. When I loaded it up, it said I had an error on it, and they said to try to fix it, but I want to make sure I have it right. So now I have a p-value of 0.01938.
Yeah.
So 0.019 for P. Is that what you guys have? Is 0.019?
Yes.
Yeah.
That is what I have.
You guys killing me here. Way behind, I feel like. All right. Financial economist is studying married couples in which both spouses work. He wants to compare the mean income earned by husbands with the mean income earned by their wives. Should he use independent samplings or dependent samplings, and why?
It's
Dependent.
Dependent, because the wife or the husband chooses, or if you choose the husband, it chooses the wife for you, right?
Yeah.
So dependent, he needs to select couples for a sample. So whether a particular wife is included depends on whether her husband is included.
Yep.
Yes.
So
That
B.
is correct. Yep.
All right.
Okay. So, okay. I think it's somebody else's turn.
Pressures of supply and demand act directly on the prices of airline tickets. As the seats available on the plane begin to fill, the airlines raise the price. If the seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. Ali Henrich, a BYU Idaho student, wanted to determine if there is a difference in the price of tickets listed 90 days before the flight compared to 14 days before the same flight. For her study, she compared the prices of one-way flights from London's Heathrow Airport to various destinations in Europe using Travelocity.com. She recorded the lowest published fares for 90 nonstop midweek flights 90 days in advance, and then found the lowest published price for the same destination, again 14 days in advance. The prices in US dollars are given in the file direct flight costs. Notice that for some designations, flights were not available. What is the p-value for this test?
Boy.
Okay.
Glad we get
So this
another
is,
one.
This is a paired sample test, correct?
Yes.
Yes.
Okay. I want to make sure before I start acting up here.
Direct flights.
What just happened? How come it won't load for me?
So variable 1 will be the 14, and then variable 2 will be the 90 days, correct?
Variable 1 would be 90
yes.
days, right?
No, it's variable 1, not 14.
It says that 90 days compared with 14 days,
14
right?
days. Oh.
Doesn't it say that?
Yeah.
90 days. Okay, so the 90 will be the variable 1. Okay.
So we're going with the 90 days as the first variable.
Mm-hmm.
And there's 2 different airports, right?
Yeah.
Well, one of them's to one from one.
Oh.
All of them.
So we need all of
at
it.
Heathrow.
So we need all of it, right?
Yeah.
Okay.
So the p-value I got is 0.096.
A paired sample t-test. Variable 1 is 90 days, right? And variable 2 is 15 days. Okay.
So which way are we going? Just because
we said 90 days is the variable 1, and then 14 days is the variable. Says that 90 days before a flight compared with 14 days. So 90 compared with 14. So 90 will be variable 1.
Okay. And I want to say it doesn't matter, does it, for this one?
I don't think so.
I think it's the differences, and you just get negative instead of positive or something.
Yeah.
I feel sorry for my wife. I can hear both of my kids crying.
What's our no on this one? That there is not a difference? Yes. That's what we want.
Oh, wait. So did you guys already get 15?
So what I got was, what are we looking for again?
The p-value was 0.0956,
56,
but you have to round it. So it's 0.1? No, 0.096. Yep. Sorry, 0.096. And 16, based on the results of the test, you can say that there is a difference in the cost of airline tickets purchased 90 days in advance compared with 14 days in advance. Use the level of significance of 0.05. Yes, because the level of no, it's greater than.
Yeah, so we failed to reject.
Yes, so there is no difference. So no, because the p-value was greater than the level of significance. A. Does that sound right?
Yeah, did you guys do you guys did the 90 days first and then the 14-day second, right? Or did you do it the other way around?
No, I did 90 days first.
Okay, so did anybody switch those and see if we got a different p-value, or does it come up the same? Is that going to matter?
I can check real quick. Hold on.
So I got 0.101 for p-value.
And you had them the other way around?
Yeah.
0.101. So maybe it does matter.
But for some reason, the first 6 values, it doesn't show a difference when there is a difference.
Oh, did you delete that? Did you, when you were clearing the data from earlier, did you delete those ones?
Yeah, I deleted, I cleared the whole thing.
Yeah, so just copy and paste the function from the lower cells into the upper cells.
Yes. That might change stuff.
I know there's a problem.
Okay, that changes it. That was enough. Just those 5 or 6 values was enough to change it to 0.0956. So
Oh, good.
Yes. So when I clear this one, I need to only do the variables, not the difference.
Oh, it's the same p-value if you do it either way.
Oh, it is. Cool.
Yeah, 0.0956.
Excellent.
All right.
So question 17.
So hold on 16 you got A though, correct?
I got A.
Yeah, because it's okay. Yeah, cool.
Question 17. A real estate company wants to evaluate 2 of their home appraisers for consistency and preparation for their annual state certification. It is important that different appraisers be able to give similar estimates for homes and other properties. The company selects a random sample of 10 homes in different neighborhoods around the city and independently asks each appraiser for an estimate of the home value. After they receive the estimates for each home, the company subtracts the value given by the first appraiser from the value given by the second appraiser. They create a QQ plot of the differences to see that the plots in the plot roughly form a straight line. Are the requirements for using the desired confidence interval satisfied? Straight line. So not a slanty line.
I think it would be C. Yes, the distribution of mean differences is normally because the data have normal.
Okay.
So C.
Because the data have been determined to be normal.
Yeah, the QQ plot determines it's normal if it's a straight line.
Yeah.
Right. Okay. Yeah.
Okay. So now 18. Now suppose the company of the previous question wants to use a hypothesis test to determine whether the estimates given by the 2 appraisers are different. Which of the following will be the most appropriate pair of hypotheses for such a test? I think it will be the first one, A.
Yeah.
Yeah.
Yeah. 19.
Suppose you can create 95% confidence interval for a mean and get -2.346 and an upper value of 8.775. You've been told to report this by saying we are 95% confident that the true mean is between -2 and the upper value. Exactly what does this mean? It says 95% of all 95% confidence contain the true mean?
Yes.
Yes. Because A says chance.
Right.
C says data. And D says sample mean, and we're looking for true mean.
Okay.
So yeah.
Okay.
20. If P equals 4 out of 5, what is the smallest value of N that satisfies the requirements for a normally distributed P hat?
The smallest value of N that satisfies the requirements for normally distributed.
The smallest
So that's
5?
Yeah, because P goes to X over N. So N in this case is 5. I'd say 5.
in P is greater than 10 and in
It's 10.
minus P is greater than 10.
So what is the smallest value of n that satisfies the requirements?
I remember there's a value there. There's a formula for that somewhere.
You don't have to just mess around with it and guess.
I mean, you can.
So it's.
I think it'd be 13.
And it's 13 divided by. No.
But how do you determine 13?
Oh, 4. So you're doing 4 divided by 5, which gives you 0.8, right?
No, that doesn't. That only satisfies the one. That only satisfies n times p is greater than 10, but not the n times 1 minus p. So, so 50? Where is it? I think it might be 50. Smallest.
Where did I? Oh, there we are. Okay.
So I think I found it here, guys. Let me share my screen real quick, and I'll show you if you guys see if this is familiar.
All right.
So sample size with a prior estimate and sample size with no prior estimate. So n equals. We don't have any of this information, do we?
No, we just have p.
Yeah, just p. What
Just
value
P.
satisfies? So what's the formula for?
Well, n equals z score divided by 2. Yeah, we don't even have any of that.
That's sample size.
That's sample size. Oh.
So lesson 16, we're working with sample proportion. And it's NP is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. So in order for the second equation to be true, N has to be 50. So N, yeah.
This is a tough one.
If P. Well, isn't P proportion? Isn't that what we're talking about?
Yeah.
We're trying to find the smallest. Yeah. So you're saying 50? So 0.2 times 50?
Yeah.
10. You're right, I think. That satisfies the requirement for a normally distributed P. And this is saying...
What's the smallest value of n that satisfies the requirements for normal distribution?
I think Thane's right. I think it's 10.
10, yeah, I think it's 10 too.
Because both 0.8 times n and 0.2 times n have to be greater than, or at least 10.
Yeah.
And so if you divide 10 by 0.2, that should give you your answer. Right?
So, okay. So you guys are using the NP is greater than or equal to 10.
Yeah, it needs to be at least 10.
and n times 1 minus p is greater than or equal to 10.
Yeah.
Right. And you can find that by doing that backwards. So you do 1 minus p, and then you divide 10, which is the smallest value, by 1 minus p.
And we have p as 0.8, right?
Right. Which should give you 50.
So we're talking 50. That's what we're going with. Okay. 50.
So the answer is 50?
Correct.
Not 10? Okay.
So, okay.
Okay.
Okay, 21. Your little brother has a career batting average of 0.233. You want to determine if the probability that he will have a batting average of over 0.250 next season when he will be up to bat 40 times. Are the conditions met so that the sample proportion will be approximately normal? I believe so. Yes, there is a large sample.
Sample of 40, so it's greater than 30.
Right. But I didn't do the test.
So,
Can you even do the test? So p hat is the probability, which is x over n. So x is the standard, the mean. X is the mean.
X will be the 0.250 on it.
Right. So 250 of the, yeah, so
40 times 0.250.
40 divided by, right?
No, 0.250 divided by 40.
Divided by 40, yeah. 0.250 divided by 40 is
0.00625.
And that gives you the p-value.
Wait a minute, wouldn't the p-value be 0.25? And the n value would be 40?
I think you're right, yeah, so.
So n times 0.25 is 10, and 40 times 1 minus 0.250 equals 30.
So yes, it is.
So yes. But let's see.
But which one is it? So the conditions are satisfied? So the conditions are not satisfied. But I mean, either one of those don't cover both situations.
Right.
Yeah.
So I think it's 30. I think it's the large sample.
But B covers one of the conditions.
So conditions are satisfied.
Yeah, I'm leaning more on B than on A.
Yeah, probably B. I think you're right, because that's the right way to test it for the probability.
Yep. So, okay, 22. Whose turn is it? Is it mine?
Go ahead.
Okay. A geneticist takes a sample random of n is equals to 140. What is it? Whatever that is, sex cells from the testis of a dog to determine the proportion which contain the chromosomes for development into a male. Assume the unknown true proportion of dog, whatever that is, that contain the male chromosomes is 46%. The geneticist conducts a survey and calculates p hat equals to 0.512. Which one of the following is the most correct interpretation of the statistics? We have to do no chances out.
51% of all the.
I think it's D. 51.2% of the gametes
in the sample.
have.
I think you're right.
Yeah.
Yeah, because it's not chance. And it's not 51.2 of the eggs fertilized with gametes were produced, because that's saying population.
Yeah.
Yeah. Okay. Next one.
We're on 23.
Right. Researchers published a study in which they considered the incidence among the elderly of various mental health conditions such as dementia, bipolar disorder, obsessive compulsive disorder, delirium, and Alzheimer's disease. In the U.S., 45% of adults over 65 suffer from one or more of the conditions considered in the study. Calculate the probability that fewer than 320 out of the 750 adults over 65 in the study suffer from one or more of the conditions under consideration. Give your answer accurate to 3 different places.
So 45% of 65. So the
Shouldn't
45.
Aren't we supposed to plug this into
one of the Excels?
Yeah.
It's the p-hat one, isn't it?
Yeah, which one's that? Oh, is that the quantitative?
Sorry, excuse me.
Categorical data analysis.
Oh, yeah. Categorical.
So the one proportion. So X is the 320. 320, right? And N is the... Okay, no, I'm wrong. Hold on.
The mu would be...
The N would be 750. The X would be 320, right?
320 is the X, and then N is 750. And then confidence interval is 95, right?
Confidence is 95.
And the null hypothesis is 0.45?
For the percentage.
Right?
Oh my
45%.
gosh, yes.
And then you're trying to find fewer than, so less than.
I'm confused. Are we doing this on the one sample t-test?
One sample z-test.
One sample z-test?
No, one proportion.
Oh, yeah, one proportion.
Categorical data.
Okay, which Excel file is that in?
Categorical data. Excel file.
Yeah, it's a different Excel.
Oh, the head one.
So you have 13 files open in Excel.
I had to close one of my things because I left it blank, and every time I would touch anything in Excel, in any of my Excels, it would go pring, pring.
Oh my goodness. I've been closing them as I go.
Yeah, I need to do that.
It's 45 or 0.45.
The null is 0.45, yeah.
45, yeah.
And then type of test is less than.
Less than.
And then we're trying to find the probability, which is p-hat, right?
P-hat 0.427.
That would be the p-value.
Did you say greater than or less than?
Less than.
Less than.
Yeah.
Wouldn't that be the p-value?
What, 0.099?
Or the p-hat value?
I think it's p.
No, the p is 0.099, isn't it?
0.099 is the p-value, yeah.
But ain't you looking for p-hat in this case?
I am not positive.
I think that's what we're after.
P-hat, so 0.427.
Okay.
All right, suppose you're testing, are we ready? 24?
Yep.
Suppose you're testing
null hypothesis. P equals 0.62 against alternative hypothesis. P is not equal to 0.62. You have calculated the test statistics to be Z equals 1.334. The area to the right of the Z score under the standard normal density curve is
0.091. Which of the following is the p-value of your hypothesis test?
Okay, so the z-score.
That's given to us.
Isn't it? Hold on.
091.
Yeah, 0.091.
The area to the right
Of the z. And you're trying to find not equal, so it'd be double that, wouldn't it?
Double it. Yes. Sorry.
Yeah.
Good call.
So 0.182.
Yes.
Yeah.
0.182.
Okay.
I remember on the last exam they had one of those tricky ones like that too.
Yeah.
Where I thought it gave it to us, but then after you read through it, you have to determine if it's talking the right or the left or both, or
yeah. Suppose you are a dog breeder and you want to use a confidence interval to estimate the true mean fertility levels of purebred Cocker Spaniels. It is known that the distribution of fertility levels of Cocker Spaniels is normal. How many measurements must you have in order to be sure the sampling distribution of X bar is normal? X bar is the mean.
Yeah. So
sample mean.
The sample mean, yep. And so it's n is equal to or greater than 30.
Mm-hmm.
A.
Okay.
True mean, yeah. No, it is known that the distribution.
Yeah, because
wait a minute. It is known that the distribution of fertility levels in Cocker Spaniels is normal. If it's already known that it's normal, it doesn't matter what your size is, right?
Oh, any n will do. The bottom one.
Right?
I think you're right, yeah.
That's what I was getting at.
Yeah. You're right. People apply statistics to all sorts of things, don't they?
Oh, man, I'll tell you what. Let's see, 26. A study is planned to compare the proportion of men who dislike anchovies with the proportion of women who dislike anchovies. The study seeks to determine if the proportions of men and women who dislike anchovies are different. The sample of 41 men was taken, and the p-hat estimate for the true proportion of men who dislike the anchovies was determined to be 0.67. A sample of 56 women was also taken, and the p-hat estimate for the true proportion of women who dislike anchovies was determined to be 0.84. Are the requirements satisfied to perform this hypothesis test, and why?
I think, is it, let's see. Yes, because 56 women. It should be.
Yeah.
I didn't do the calculations, but it should be.
41.
So
Yes, because the sample sizes in both groups are
7. Yeah.
I think it's yes because in both cases n times p is greater than 10.
Well, that's p hat though.
Oh, p.
this is a two proportion test, right?
Yeah.
So it says in my little. I think I've got this somewhere else.
I think that is our answer though.
What is it?
So n1 p hat 1 is greater than 10. N2 p hat 2 is greater than 10. And then n times 1 minus p1 is greater than 10, and n2 times 1 minus p2 is greater than 10.
So, yes, B?
Yeah. I don't know why they have p hat there though, but.
Wait, D?
Well, p hat. So you would go on the men group, right? You would go 41 times 0.67. And then 41 1 minus 0.67. Right? That one's both correct. And then 56 times 0.84 is correct.
But 56 times 1 minus 0.84, that's not correct.
And hold on. Oh, you know what? This is.
Is that wrong?
Oh, no, we're good still. Hold on. 56, 1 minus 0.84 equals 8.96.
Yeah, so.
Oh, so we know, because in at least one case, n times 1 minus p is less than 10.
Yeah.
So that's the answer.
Yep.
Oh, well.
I was gonna say we could have plugged that in. I was trying to figure out how to plug that into the Excel spreadsheet, but you'd have to sit there and guess till you got the percentages right. You know what I'm saying?
Mm-hmm.
Okay.
Oof.
A study was conducted to measure the effectiveness of a diet program that claims to help manage weight. Subjects were randomly selected to participate. Before beginning the program, each participant was given a score based on his or her fitness level. After 6 months of following the diet, each participant received another score. The study wanted to test whether there was a difference between before and after scores. What is the correct alternative hypothesis for this analysis?
D? Well, no, sorry, B. Right? The difference? You're going after the difference?
Yep.
Mm-hmm.
The mu difference would not be equal to 0.
Yeah.
Okay. Weight Watchers wanted to predict how much weight a client would lose if they followed a prescribed exercise program in addition to their diet program. Volunteers were randomly divided into 2 groups. One group dieted but didn't exercise, and the other group dieted and followed the exercise program. For the exercise group, they used linear regression with percent compliance with exercise program as the explanatory variable, and pounds lost in 3 months as the response variable. One of the clients was told that his residual was 5.5 pounds. What does this mean?
Okay.
So it's a two groups. Yeah, it's a 2 group. Sorry, one second. I'm looking at it's quantitative inference, a linear regression, right?
Yeah, but we just did residuals this lesson. And that was the difference.
Yeah, that was on the, what do you call that thing? Linear regression, the residual, so.
Yeah.
How would you do that?
So let's see here. Let's look at let's see. We're on 30.
The error term.
So your residual plot. Residuals. The residual for an observation is defined as the difference between the observed value of y and the value that would have been predicted by the regression line. As an equation, this is expressed as. Okay, so it says that his predicted weight loss? His
residual was 5.5.
Right, which would have been
5 pounds higher than his actual weight loss?
That would have been so a residual is the difference between the observed value of y and the value that would have been. So that's the difference.
Yeah.
So the actual weight loss was 5.5 pounds higher than the predicted weight loss?
I believe so.
Yeah.
So if so is it B or C?
His actual weight loss was 5 pounds higher than it would have been if he
No,
didn't
It's
exercise.
B.
No. It would be B. Because
for the exercise group, they used linear regression.
Yeah,
with
it's for the exercise group.
Mm-hmm.
One of the
So
classes told me.
that's what it was. It's B, I think.
Yeah.
So read the residual definition again that you just read.
The residual for an observation is defined as the difference between the observed value of y and the value that would have been predicted by the regression line.
Yeah.
So
it's the difference between the
actual weight
observed
loss
value and
higher than the predicted.
the regression line.
Yeah. And so it's positive, so it's higher.
Mm-hmm.
So
it's
B.
B.
So that is B. Okay. Okay. I just wanted to try to wrap my head around that a little bit better.
Okay.
Not a problem.
For the study in the previous question, the B1 of the regression line was 5 pounds. Interpret this statistics.
Interpret this statistic.
Uh-huh.
The B1 of the regression line was 5 pounds.
So the slope is 5. So
as percent compliant goes up by 1%. No.
Is it not B on the average exercise participant lost 5 pounds more than non-exercises?
Yeah.
Are we all agreed?
Because the two data you're comparing are exercise and not exercise. Well, not exercise to exercise, correct?
Yeah.
Mm-hmm.
And so they're saying the regression is the difference between the observed y. Huh. The average weight loss of all participants, no. On average, the exercise participants lost 5 pounds more than the non-exercisers. So they're doing it with a difference. So it's a quantitative reference. So yeah, you're finding the residuals.
See, this is the part where these last 2 or 3 lessons has just completely lost me. Because B1 is the slope, right?
Right.
Yeah.
Right. And so of the regression line. So for the study in the previous question, the B1 of the regression line was 5 pounds. Interpret this statistic. So the slope, we need to, what's the definition of slope?
Rise over run. Change in rise over run. So it changes 5.
So for every 1% on average, 5 pounds are lost in 3 months. Is that not?
No. No.
Percent compliance goes up by 1%.
Because we don't have any percentage given. Or yes, we do.
As percent compliance.
Yes. Maybe that is it then.
Because
so
the slope is
regression with percent compliance.
Yep.
Because the slope value is how much. Yeah. So the slope value you're using, you should be timesing x by slope, right?
Yeah.
Well, for the exercise in the example, it says for exercise group, they used the linear regression with the percent compliance with the exercise program as the explanatory variable and the pounds lost in 3 months as the response variable.
Yeah.
So slope is going to be percent compliance to pounds lost in 3 months.
Yep. That's
okay.
Yeah.
So it is C.
Is
okay.
Man, these are getting harder. Brain is going down.
I know. And later in the evening, harder questions. No.
Yeah.
What are you doing to us?
So we had this on our chapter quiz.
When creating a scatter plot, a residual plot, and a QQ plot, which of the 5?
Oh, it's A, B, C.
A, B, C. Now watch us miss it on this one.
No, it's not.
Wait. On the previous one, did we say the final answer was B?
Wait, hold on. I'm looking it up.
It's B.
It's 20. Was it 23? Yeah, okay. So the linear relationship
between X and Y. So A, B, C, D.
So D.
The error term is normally distributed. Residuals are so B. And the variance of error terms consistent.
Consistent.
That's E. So the X's are fixed and the observations are independent cannot be.
Okay. So we should have B, D, and E.
Correct.
Man,
okay, I have a question about 29. 29, did we agree that it's B?
What was it?
Say that again?
On number 29, which one did you say was the final one? Was it B?
Oh, C.
Oh, C. Sorry.
C. Okay, gotcha. Just want to verify. Okay. All right. Okay, so moving to this one.
Next
is the direct
questions.
flight one. Pressures of supply and demand act directly on the price of airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If seats on a flight do not sell when an airline may discount tickets or even cancel the flight. Ali Henry, a BU Idaho student, wanted to predict the price of tickets 14 days before a flight based on the price listed 90 days. So this time we're switching them, right? Because he wants to predict 14.
Yeah, 90 will be the X value. No.
No, 90 will be the Y value.
Wanted to predict the tickets of 14 days. Right, so 14 is what you're trying to predict. Which would be Y.
So 14 will be the Y, okay. For her study, she compares the prices of one-way tickets from Heathrow, blah, blah, blah. So pretty much this is the same. The price in dollars given in the table.
Now I just need the data.
Okay, another one, the R, the correlation coefficient.
So direct flights data.
Which is 0.990, I believe.
So 90 is going to be the X variable or the Y variable?
90 is the X. Because you're trying to predict the 14. And so we're in quantitative inference, linear regression. 90 is the X.
And we're in linear regression, correct?
Yes.
Mm-hmm.
So let me just read my B1 just to see if I've got the right numbers in here.
Okay.
I got 0.627, 0.054, 11.510.
I also have that.
P-value is like -19, 4.246. And then confidence intervals is 0.518 and 0.735. Okay.
That's what I have.
All right.
Okay. So 31, we're looking for the sample correlation coefficient.
So okay. I'm slow this time.
Oh.
So we're going. X is 90 days.
X is 90. Yep. For price of tickets, compared to give your answer accurate too. So the coefficient is R, right?
0.780.
That's what I got. Getting there. Create a scatter plot using these two variables, using this scatter plot, and referring to the correlation coefficient, select the answer that best describes the data illustrated in the scatter plot. Oh boy. Scatter plot using the residuals?
0.780 is the correct correlation value.
Mm-hmm.
Okay.
Create a scatter plot using these two variables. So it makes the scatter plot for you.
Yeah.
Yeah.
Right.
Okay, so use that scatter plot. Okay, so it's a, oh dear.
Do you guys have a bunch of data down on the corner and then a couple of outliners?
Yep.
Yeah.
Yeah. So it's what, a linear with a fairly strong positive? Because there's only two outliers, really.
But remember the coefficient is from 1 to -1.
Yeah.
And 1 or -1 is a strong. And if it's positive, so that would be a strong positive.
Yeah.
Right, since it's almost 1,
I think
right?
it's linear, right?
Yeah.
Yeah.
No. With
Yeah.
fairly strong positive.
You wouldn't say that's linear? Non-linear?
Well, you got that one.
Yeah, it's like
number,
way down there.
But
see, I is it on 22 or 23 homework? Or 20, one of them I had one of these questions and I did both the positives and it turned out to be non-linear. And like I said, this is really interpretation wise because
Yeah. Does it look like a megaphone?
I mean, all our data is pretty scattered, pretty clumpy down here, but it would be strong because our our R is almost at 1, and it's a positive number.
I think it's linear with a fairly strong positive.
Yeah, that's what I think.
A strong positive, so B.
Yeah.
Okay.
I mean, it might be non-linear, but it looks pretty.
Well, if we miss that one, then we know it's non-linear because it would be a negative number if it was a negative.
If I get that one wrong, I'm not doing this whole thing again.
Oh yeah, I'm not either. I'm so tired right now. I'm like, when I'm done, I'm done.
We have till Thursday to do this, though, right?
Yeah.
I believe so.
Okay.
Okay, and the y-intercept is 115.640.
The 115.640. 115.640.
Okay.
And the slope is going to be 0.627.
Yeah. Let's
Predicted price of tickets listed 1484.
Yeah.
That's when you predict by putting the X, which is the cost of the
so the X is $200. And the predicted value is 240.979. Accurate to one decimal place. So 241.
Yeah, 241.0.
Because you'd have to round 7 into 9, which would make it 10.
Yeah.
I just did the Excel feature to make it one decimal places. It put as 241.0.
Yeah, 241.0.
Yeah.
Okay.
The lower one, we have 0.518.
We only got 12 questions left.
Yep.
Killing it.
What was that, George?
The lower we've got 0.518.
Oh, the low bound?
Is that for the same, for the next 3 questions, construct a 95% confidence interval for the slope regression obtained using 90 days before. Okay, yeah. 90 days to predict 14 days. Yeah, that's right. So the lower bound
is 0.518, and the higher is 0.735.
Upper bound 0.735. Okay.
And
Margin of error.
Higher minus lower divided by 2.
Yeah.
Which is 0.109.
735 minus 8.
so
2. I got 0.1085.
Yeah, that ends up being
0.10.
0.109.
Yeah, 0.109.
0.109. Mm-hmm.
Okay.
next 4 questions. Conduct a hypothesis test to determine the slope of true linear regression line is not equal to 0. Choose the best null and alternative. So B1 is equal to 0 and B1 is not equal to 0. D.
Because we're doing the
Yeah,
slope.
the bottom one. Mm-hmm.
Yeah.
And the value of the test statistic, that is 11.510.
11.510.
That's the t value. The slope.
Yep. And now what is the p value, which is 0.000.
Yep.
0.000.
And then what decision do you take based on the p value? Okay, so
reject the null, right?
Below, we reject the null.
Sufficient evidence to suggest.
Yeah, C, right?
Correct.
Okay.
Cruising along.
What's the difference between? No, it's going to be.
Oh wait.
Oh yeah. C. There is sufficient evidence.
Yep.
Okay, and now we get into those interesting ones.
In the United States, mothers who live in poverty generally have babies with lower birth weights than those who do not live in poverty. The mean birth weight for babies born in the U.S. to mothers living in poverty is approximately 2,800 grams. Who measures in grams in the United States? The CDC.
Well, we do in South Africa.
The CDC does.
Yeah, the CDC carries out a study to test the effectiveness of the new prenatal care program in reducing the number of low birth weight babies born. For the study, 30 mothers, all of whom live in poverty, participate in the program. Birth weight data is recorded. Which hypothesis test would be most appropriate for this study? So it's a one sample
t-test,
I think, because you're testing to see you have an X. I mean, you have your null is 2,800 grams.
Right.
And you're trying to see if there's a difference from that.
If they go through this program, if there's a difference in that from that weight.
Right.
The one sample t-test. I agree.
Participate in the program. Right.
Yeah, and the mean is known. So it should be one sample t-test.
Reducing the number of low weight births. I wonder if is that proportion?
No, because it would say proportion.
Yeah.
Okay.
Okay.
Yeah, because you're trying to find the after this study, the 30 babies would be weighed, and it would be compared to the 2,800 grams.
Right. Yeah.
So the mean. Yeah.
Okay.
Engineers at an oil refinery find out how easily gasoline evaporates by measuring its vapor pressure. As they make gasoline, they need to determine whether its vapor pressure is high enough. The standard deviation of vapor pressure of the gasoline made by the refinery is always 0.03 pounds per square inch. Which hypothesis test would be the most appropriate for this task? The one sample Z, because sigma is given.
Yeah.
Okay. There's so many different options. I'm gonna get all these wrong. An attorney wants to know whether the percentage of Walmart employees in Nevada who are over 45 years old is more than 30%. Which procedure would be most appropriate? Is a one proportion, right? Test of one proportion.
Yeah, I mean the percent would be right.
Yeah. Yep, I think so. Are we good?
I think so.
Yeah.
Okay.
Test of one proportion.
Okay. A marriage counselor conducted a study of couples, categorizing each of the couples as communicative or non-communicative. Among other things, the counselor wanted to see whether the percentage of communicative couples whose marriage ended in separation or divorce was the same as the percentage of non-communicative couples whose marriage ended in separation or divorce. Which hypothesis test would be most appropriate for this study?
Chi-squared?
Yeah.
I think so.
Because you have 4 groups, right? You have communicative that divorced or not, and non-communicative that divorced or not.
Yeah.
Mm-hmm.
You are right.
A business marketing firm specializes in radio advertising. They hope to show there is a linear relationship between sales and the amount of money a client invests in his radio advertising. Which procedure would be most appropriate for addressing this question? Well, being as it says linear, I'm going with linear.
Relationship between sales
A
and
linear regression.
yeah, because you're going.
You're going to try and
because
you have a dependent and independent variable. You're trying to predict how much you'd save by how much money you invest in radio advertising.
and you want to show the linear relationship.
Okay, I'm submitting this thing.
Thank goodness.
See how we did.
Done.
I got 42 out of 47. We got 40. I got 46 wrong.
You got 46 wrong?
Yeah. And let's see what else we got wrong. 46 was wrong. And
so what is that going to be at?
It's 2, probably.
Two
That's the only other
proportion?
thing I could think of it being.
Wait. What do I think? I was thinking it could be maybe a paired sample t-test.
You think?
No, because you're doing proportions. You're doing percentages.
Oh.
You wanted to see whether the percentage of communicative couples whose marriage ended in separation or divorce was the same as the percentage of non-communicative who ended in separate. Oh, that is a 2 proportion. Because it's only doing who got separated from each of the 2.
Mm-hmm.
I missed that. Sorry, guys.
No, not a problem.
What else did we miss, Wes?
I got 23 wrong.
I think we're all a bit tired.
Yeah.
Yeah, we are.
What is 23?
23, I got 0.427.
That's what I have.
Yeah, that's what I have too.
How did we calculate that? That was calculate the probability. That was
23, I got 0.099.
0.099 is what you got?
Yeah.
That's the probability?
That was the p-value.
It's the p-value, is it? What are we looking for in this? Let's see.
It's the probability that fewer than 320 out of 750 adults over the age of 65 will suffer from one or more conditions under the current consideration.
Oh, so will that be the p-value?
Yeah.
So 0.099?
Yeah.
That's what thing you got. And then 21 I got wrong.
Yeah.
Which was, yes, 40 times 0.250 is greater than 10.
That's 29?
I'm not sure what it should have been.
No. What number? What question number?
This is the batting average one.
Oh, 21.
Oh, 21. Okay.
Are the conditions met?
Did I choose the right one? 40 times.
Which one did you choose?
I got a B.
I got it wrong.
B was wrong. Should have been A, maybe?
Yes, there's a large enough sample size, so the sample proportion must be normal. Doesn't it have to do the 2 conditions, though, in order to be?
I'm not sure. Because your brother's batting average is that, and it's trying to determine whether the Z the probability. So you'd find one sample t-test.
Because
Should still be that other
probability, don't you have to do? Oh, that's proportion.
Has to be.
Is that NP greater than 10 and N minus 1P greater than 10?
Well,
it should be. Aren't there more than one requirement, though?
Yeah, but the last one is true.
Oh, the no one.
But it's probability.
40 times 0.233. Yeah, that's right. No, 40 times is conditions are not met. I think that's the right answer is D.
D. Try D.
Okay. And then 18 we got wrong. Now suppose the company of the previous question wants to use a hypothesis to determine whether the estimates given by the two appraisers are different.
Oh, it's C.
It's
Yeah,
C.
it's C. It should have been C. I had A.
I did too. Yeah, C.
Yeah, because you're testing the differences. And then let's see, did I get any other ones wrong? I think that was the last one. Oh, wait. It's 4. We missed that one? The median. Oh. Darn it. It's asking the median, not the mean.
Will the median change?
Yeah. That tricksy question. The median is the middle value.
So if it's 12 and you change that to 21, it'll decrease.
No.
It'll stay the same.
Yeah, the middle will still be the middle.
Yeah, the middle value will still be 21 probably. It might not be possible. It's not possible to determine this without the full data set because you don't know what the middle number is.
That's true.
Let's get that view here.
Because you'd have to be able to see the middle number. Because if it got changed to 21 and that changes, that becomes the new middle, then it might be different. It's very likely that the median would stay the same, but it's not possible to determine. I think it's C. Because the median is the middle value. And then that's the last one that we got wrong.
Okay. Well,
Mean, median, and mean.
Well, guys, it's been fun.
Yeah.
It's been real.
This is the last. This is our last meeting, right?
I believe
So
so.
I think we have one next week.
Do we have one next week?
For the review? I thought
No,
this
no,
was
no.
one for review.
Review.
Yeah, I think this is the last one.
What did
The
we
last
get?
one. Oh, okay.
What
Because
did we
next
get?
week all you have is the final. Right? Week 14. Oh wait, there is a group meeting. 25 individual preparation.
Right.
Yeah, that's what I saw.
I just got 46 out of 47. Which one did I miss?
Uh-oh.
4.
Yeah, so we will see each other next Tuesday.
I missed 4.
Oh dear. I closed it already.
So it's not going to stay the same and it's not going to increase. So
It will decrease.
So I think it's impossible to tell. Right?
Yeah.
Is that what you had?
I had the median will stay the same. So
I think it's impossible to tell one.
Impossible to tell.
Yeah, it is impossible to tell.
Because it shouldn't decrease if they're
Well, it should.
increasing that value, so it shouldn't.
Yeah.
But unless you have the whole data set, you're not going to be able to tell for sure what the actual outcome is of that change.
Yeah. I used that one. It is not impossible to determine it at the full data. I got 47.
Oh, you said impossible to determine?
Yep, that's the right one.
And what was the other one you got wrong?
I got all of them right.
Oh, you got them all right?
George got 100%.
Good.
So we can save this and then go back some other time before Thursday and redo it. And right? All right, man.
Yep.
Yeah, because I'm tired. I'm going to bed.
I
guys,
too.
yeah.
You guys.
It's been fun. It's been real.
It's been great. You guys have been an outstanding group. I really appreciate all your help.
If this is a good indicator of how we're going to do on the exam, then we'll be all right.
Yeah, we'll be all right.
Yeah.
I'll still find out what the median or the
average
class average will be for the final. I don't know if they'll tell us on that, but oh well.
I think I'll do that too. I'll send an email to the TA and be like, "Hey, what's the average?"
Yeah, for sure.
I don't know.
All right, guys.
Yeah. See you later.
Ethan, have